All right. Let's do view share settings. Can I maybe... Let's stop sharing. Okay, it's not shared anymore. Let's share presentation. I'll copy this because I need to do view only on this one now. Okay, so I'll copy this. Let me make sure the link is updated in here. Well, it looks like it was still the same link. No, it's the same thing. I can't answer the question. Is there a way for me to force it? So like an iCloud preferences? Here, let's just make a quick little change here. Then we're going to save it. And then let's reload this. It's possible that the internet was down the last time I made a change. Let's change it to allow editing as well. Okay, well, it told me it's editable now. There's that. Let's close this. Let's go open. Let's try to directly open it from iCloud. I wonder if maybe I haven't. No, it says today this is on iCloud. I have no idea. I have no idea. What I can do is just remind me right after class. If any of you are interested in the slides, I'll just do a quick share and I'll just put all your email addresses in. Actually, just do this. Somebody remind me after class and I'll just do it. I'll send it to everybody. Because for some reason the link is not working and it's got to be an iCloud problem because you've seen you've seen me do it. So I don't know. It's a share thing. So I apologize. But it doesn't change from this week to next week. So after we're done today, just somebody yell at me and I'll just shoot out a copy to everybody and then you'll just have it. And at some point, It could be an iCloud bug, or maybe there's a setting or something like this. Okay, so let's do the coding assignment for today, and then as we kind of go through that, well, actually, just quickly, let's spend 5 minutes or so talking about the homework, the paper side of things that talked about having different ways of storing information, whether it be binary, octal, decimal, hexadecimal, kind of our four go-to ones. Why do we need different ways of representing data like that?
Every way has its own advantage and disadvantage. How we use it.
Okay.
Like, for example, the hexadecimal is good for big numbers like colors and HTML. We use it a lot for me.
Okay, for hex.
Yeah.
Why? Why do they use hexadecimal for colors?
Because it has every color has 255, I think, range of colors.
Mm-hmm.
And the 16-bit is much better than the binary or the decimal.
Okay, so each RGB, red, green, blue, for color palette has 256 unique colors, 0 to 255, right? Which is an 8-bit, number, correct? It's an unsigned 8-bit number, because a signed 8-bit number, signed 1-byte number is negative 128 to positive 127. So if you want to get the full 256, you make it unsigned. No harm, no foul. So you have red, green, blue, right? So for the red, you have 0 to 255. For the green, you have 0 to 255. For the blue, you have 0 to 255. So that means you have 24 total bits for that value, correct? To represent it. So 24 bits, 2 to the 24th power is 16,777,216. Okay, so that would be 0 to 16,777,215 would be the range of values. All right, so rather than have you put in, I want color number 14,123,047, you can now put in a hexadecimal value where every 2 jumps is every 2-digit hexadecimal value is going to be one of those numbers, right? Okay. Now the reality is hexadecimal is 16 bits, or is a base 16, correct?
Yeah.
Hexadecimal is base 16. So the question is when you do RGB for your color palette, is it actually a 24-bit color, or is it higher color than that?
I think 32.
Yeah, it's 32. It's higher bits. So this problem would become even worse if you still represented it as decimal. Okay, so now this would become 2 to the 32nd power, which is 0 to 4 billion. Make sense? So in order to pick the perfect shade of red that you were interested in, you're going to say, I actually want color number 4,113,261,241. That's the exact color I want. Make sense? So hexadecimal allows us to more conveniently represent it. On one hand, it's a funny thing with graphic artists is, yes, you have 4 billion different colors, let's say. So somewhere between 16 million and 4 billion colors, depending on the color palette you're working with. Doesn't really matter. Hexadecimal still has a use, whether it's 24-bit or 32-bit or even 64-bit color. Now you start running into a situation, can your monitor show the difference between this blue and this blue? Make sense? There's a point where our eyes can only detect so much and our monitor technology can only show so much. So keep in mind that 128-bit color isn't better than 16-bit color if you're looking at a black and white monitor.
Yeah.
Get it? Okay. So more bits isn't necessarily better, but certainly we have pretty good technology today. So 32-bit color is with 32-bit color with really nice printing or really nice optics from a monitor certainly are doable. So you could tell the difference between a couple different shades of blue. Well, the idea is that with graphic artists today, they have kind of their go-to blues or their go-to reds or their go-to grays. So they memorize, as a graphic artist, you might have, let's say, 20 hexadecimal values that you use often. You have your favorite soft blue, and you like that particular soft blue. And even within companies, when they have logos and stuff like that, that has a certain color. Like, for instance, my company, the Awesome Fat color was red. And so we had awesome fat red, which was, I don't even remember. I don't even know I wasn't a graphic person. So whatever the hexadecimal value for awesome fat red, that's what we use for all of our stuff for red logos. Okay. So punchline is that hexadecimal allows us to represent what would otherwise be a big footprint number in a smaller space. And it also allows us to remember those numbers more easily. Okay? Yeah. If you want to take it out of the number realm, we can say the exact same example is true with our cell phones today. Example being this. So all of us in here have cell phones, right? Okay. So let's say that there's 10 people in your contact list that you call regularly. How many of you know more than 3 of those numbers by heart? Huh? You know more than 3 of those numbers by heart? You know the phone number. Yeah, but it is hard when I just pick up the phone and say, call Tabitha Littman. Or I just tap on my wife's face. The number doesn't mean anything, right? Okay? The only phone number I know is, well, I know 2. I know my own, and I know my wife's. And the only reason I know my wife's, well, I probably would know my wife's anyways, but when we got the phones, the cell phones, her number is just 2 off of mine. We have the same number, except mine's 05, hers is 07. Only difference. Okay? But I still don't even need to know her number. I would only need it if I was like on my deathbed, I didn't have my cell phone, and I would just say, she's the short blonde, and just hit her face. All right? So, yeah, it's actually interesting for those of you who've never seen me with my wife. My wife is really tiny. She's not, yeah, she's like 5'4", 110 pounds. I don't even have to buy a second airplane ticket when we fly. I just put her in my carry-on. Actually, maybe even the better advantage is this. It's not that I don't have to buy a second airplane ticket. It's that I don't have to buy a third airplane ticket because I take up 2 seats. I get a seat and a half. She gets half a seat. So you put 2 of us together, that's 2 seats, right? Except Southwest always gives me an extra seat. Oh, I love Southwest. I've only, huh? Oh my gosh, Southwest. I've flown Southwest twice now. If I ever have an opportunity to fly Southwest, I will always fly Southwest. First time I'm in line for them, this guy comes up to me, and he's trying to like, hey, could we offer you a second seat? Because I'm gravitationally challenged. I told him I'm actually just too short. If I was like 15, 16 feet tall, I'd be like average weight. You still processing that? No. You got it? Okay, so.
Let me stop recording.
Yeah, 16 feet tall, 380, that's normal weight, right? But 6'4", 380 is fat. You know what I'm saying? Yeah. All right. So in any case, he comes up and he says, hey, can we offer you another seat? It won't cost you anything. We want you to be comfortable, which is kind of like the nice way of saying we want the people next to you to be comfortable. So like, hey, sure. Not only do they give me a free seat as long as they have room on the plane, they also give me this little card. You know how like with Southwest you're like in competition to like check in enough time so you're early on in the flight since it's not assigned seats? They let me pre-board. Yeah, I don't have to wait to get on with the other steerage. I just go right up to the front desk and say, hi, I'm fat. They give me a little piece of paper that says seat reserved. So I get right on the plane, I sit right in the front where I have tons of leg room, and I got my feet propped up on the thing, and I put the paper right next to me. So I got my pocket wife, an extra free seat with this piece of paper on it, and my feet are up on the thing, and I'm chilling. When these people are getting on the plane, like fighting for seats. Love Southwest. Just love it.
I have to tell my girlfriend that she's flight attendant.
Yeah. So, is she for Southwest?
Yeah.
Also, Southwest does funny if you've ever flown. Not all the time, but they'll do funny like things. Like the flight attendants will, yeah, they do skits, and there's some really funny ones where like the flight attendant comes on and says, "Oh, welcome y'all. We'll be helping you out today. I'm, helping you out in the back is Jim, my ex-husband, his new wife, his girlfriend Lacey, and our divorce attorney Chuck," or something like that. I haven't had one that interesting, but they're usually pretty bubbly. Like it seems like they're happy to work there, where a lot of flight attendants don't seem like they're all at. I've never had a bad experience in other airlines. I've had an extra good experience with Southwest. I would say that's fair. Like I'm not disappointed in other airlines. I've just been impressed with Southwest. But the funniest thing that's ever happened for us is one time when we landed we left Milwaukee, landed in Fort Lauderdale. The pilot comes over and you know how like as soon as you land, as soon as you pull up to the gate, everybody just gets up immediately, right? Starts grabbing their stuff. He goes, "All rise," kind of like you're at a church service or something like that. We rise for prayer. It's just all rise, and everybody was shot up. It was funny.
They're fun. They're very fun.
So, very pro-fat people. I like it.
I remember once my brother got married, long story short, last year in Mexico, and not only did she get us air, when we got there, she upgraded all of us to first class. And I didn't know until we...
Okay. Does Southwest have first class? Oh, and the bigger planes. Okay, so the planes that go farther, they have the bigger planes, they have multiple classes. I got you. See, I've only flown Southwest. I go to Florida fairly often. That's where my grandma... That's where my grandma lives, and that's where I golf during the cold months. So, Fort Lauderdale. She lives in Sunrise. So I fly down there, direct flight, Milwaukee to Fort Lauderdale.
3 hours.
Not even.
Yeah, right.
Man, last time it was supposed to be a 3.5-hour flight. We showed up 45 minutes early.
Yeah.
No, it was supposed to be a 3-hour flight. We showed up 45 minutes early. Guy was cooking. My ride here back in Milwaukee wasn't even here yet. We hit the ground. I told him, "Oh, everything's on time." We get to the ground. He's like, "I haven't left home." So I yelled at him and said, "What kind of door-to-door service is this?"
There's an undercover boss episode.
Huh?
About Southwest Airlines. The CEO goes undercover.
Oh, is there? Undercover boss?
I think I've seen that.
Okay. Yeah, I'm really impressed by them.
Southwest Airlines.
We've flown them twice. We flew them the first time. We were super impressed. And then now, if there's a Southwest flight, I'll pay extra. Typically, you don't have to. Typically, it's less. And your luggage flies for free. You don't have to pay for your bags.
They don't charge for your bags here.
Anyway?
I think it's up to 50 pounds and 2 bags. 2 bags a person. Doesn't cost anything.
50 pounds, that's
Now,
very
fly
good.
Spirit, anybody fly Spirit?
Yeah.
They charge you a lot, or
Charge a lot.
Yeah.
really?
But I have a way to get it around
Okay.
if anybody wants to.
Yeah. I mean, the punchline is I fly quite often, and I've never been unhappy with other planes. I mean, if anything, you might say the Southwest planes they feel a little older. They're probably a little bit older fleet of planes, but I don't have like a vendetta against any airline. I've never had a bad experience.
They give you free baggage. You can take that.
Yeah, but Southwest, really affordable, and just, it makes you feel like they like that you fly with them instead of this is the best we can do for what you paid type thing. Yeah, I don't know. I've just been impressed, so I'd give them a plug. All right, so in any case, back to reality. Okay, because unless you want to stay till 11, I'm cool.
I just wish they used Boeing, no Airbus, because I never enjoyed the Airbus before, those small ones.
Oh, why? What's
I mean, no space in there. Boeing's like, I don't know, feel more comfortable. I don't know that.
Well, an interesting thing is, those little regional jets, like the planes that'll fly from like Milwaukee to Chicago, or that you might take just to the East Coast or something like that.
Chicago back to Florida or California.
Well, I'm talking about the regional jets, the ones that have maybe like 15 rows, something like that. Those are by far more roomy than the bigger planes.
Yeah, they are.
Like leg room and stuff like that. I'll be in like a 737 and my knees are in my chest. I'm in one of these little puddle jumpers for your 12-minute flight from Milwaukee to Chicago, and I can like stretch out, leg room wise. Butt room wise, it's a whole different story. Because those jets are not made for normal today people. Today people, our butts are bigger. My wife takes up a whole one of those seats. I take up 2.5 of those seats. All right. So, in any case, advantage of hexadecimal numbers, it allows us to represent decimal numbers that are large in size in a smaller footprint. It's a convenience thing. Okay. What about binary? What's an advantage of binary? Yeah, I mean, it allows us to accurately represent digital logic. We can't represent base 2 logic, digital logic on, off, in any other base other than base 2. It's the only option. Okay, so that's why that has a purpose, binary. What about octal? Octal is always the weird bastard child.
Maybe Octal is good for Unix, for the CH mode,
Okay,
read and write, and execution.
okay. So some very specific things, but certainly octal seems to be like, it makes less sense, but it's kind of there, right? But that's actually a really good example. Change mode for rewrite execute for, because it's 2 bits. No, it's
It's G.
3 bits. Yeah. 755, 744, those types of things. So it's 0 through 7, which is a base 8 number. Make sense?
Yeah.
So in any case, these various number representations, they either have special purpose uses like that, special purpose uses like binary, or more convenience uses like memory mapping and color picking. Anytime you have to represent a really, really, really big number, by today's definition of a really big number, hexadecimal usually makes more sense because it fits in a smaller footprint. You know, eventually, a lot of times you'll see memory addresses represented as hexadecimal because we talk about, you know, your computer might have 16 gigabytes of RAM and you have to index all of those buckets of RAM. We're going to be talking about arrays today. I'm pretty sure. I haven't actually looked at your next homework assignment, but let's just say maybe. But when we talk about arrays, we're going to be talking about indexing memory. And when you have a zillion buckets of memory to index, when it's giving you a memory address, that memory address is going to be in hexadecimal rather than giving you this giant number that tells you what bucket of memory this guy lives in. Now it's this bucket of memory, even though they're the same number. So it's a representation thing. Make sense? Okay. And what about decimal? Why do we have decimal? 10 fingers, 10 toes, right? That's it. You know, my other class we talk about another use for octal is for the aliens. All the alien movies, I think the aliens, don't they always have 4 fingers?
Yeah.
See?
ET, 3 fingers?
ET's not a real alien, it's different. None of the aliens look like ET. That was a made-up alien. But I'm pretty sure all the people that talk about the big-eyed grays and stuff, I think they all have 4 fingers. So that they would be their base 8. So we need octal for chmod, for Unix, and for the aliens. Special purposes. That's actually been an interesting. There's a couple different book series I've read, but one of them is the author's Andy McDermott, and the first book is like the Hunt for Atlantis or something like that. They're looking for the lost island of Atlantis. So the book series is kind of like Indiana Jones. You've seen the movies, but it's split between 2 people. Instead of Indiana Jones being the action hero and the archaeologist, in this book you have the girl who's the super brilliant archaeologist, and then her boyfriend, original bodyguard, who's the muscle. Yeah, he's the action guy, right? So they split it between 2 people. But the reason I brought that up is one of the puzzles she had to solve in one of the books was dealing with figuring out these Atlantean writings or something. And because they had 4 fingers, or you know, they didn't actually say 4 fingers. They just said that they used the base 8 counting system instead of base 10. So that's another use. The people of the lost city of Atlantis also use base 8. So says Andy McDermott.
So do the Yukai people of California.
What's up?
So do the Yukai people of California.
Really?
I Googled it just to be sure because I read it in one of the articles.
So is that like is it an Indian reservation?
Yeah.
Okay. Do they only have?
They count between their fingers.
Oh yeah, that was it. That was it with the Atlanteans. They count between their fingers. They copied the Atlanteans.
Oh,
No,
yeah.
the book copied it. Expression. No one knows that Atlantis is really there.
What's up?
No one knows that Atlantis is really there.
Well, the book makes it sound like it is. They actually have a second book about Atlantis. It's there.
Who was the one who actually told there was Atlantis? Greek philosopher?
Yeah, Plato.
Plato, yeah. Always get confused between Plato
Yeah.
and Socrates.
All those things are really interesting.
Yeah.
Whether it's real or not, I just find that stuff is just fascinating. right?
Yeah.
Like the current book, I listen to audiobooks. I don't listen to music. So I'm currently listening to like book 8 in that series or something, which I've heard before, but I haven't heard it in a while. So they're looking for the lost city of El Dorado right now, the city of gold.
South America, gold.
Wherever, who knows where it is? All I know is there's like billions of tons of gold there. It's awesome.
Yeah, I hear that.
All right, so let's say that we got to get cooking here. All right, so let's say that's a pretty good understanding of what these multiple bases are for. Okay, convenience type stuff. So now we're supposed to write a couple of methods. Let's see, at least 2 methods: base to decimal and decimal to base. So we need to write a universal converter called base to decimal. It takes in a string representation of a number and the current base that number's in, and it should spit out as an integer that number in base 10, right? Okay, so here, let me just copy this method header here. So we'll go ahead and write that one first. I assume this homework was really easy. How many of you cheated? All of you?
Getting help.
Huh?
Institute cheating? Just
No, getting help doesn't institute cheating. But using integer.parseInt to do the... All right. What class is this? 535. All right. So let's get rid of all this crap from last time. Oh, gold. Gold gone. All right. So we are supposed to write a method called base to decimal. Now, is this a class method or an instance method? Class method. How do you know? Static. So when we see the method being defined, we know it's a class method if it has the keyword static out front. What if we see a method being called? How do we know? How are class methods called? Yeah. Using the name of the class in which the method was defined. So in this case, we would call this method by saying driver dot base to decimal. Because that's the name of the class this method was defined in, is a class called driver. All right, so base to decimal is going to take in a string representation of a number. So for example, we might take in the string BAD and say that's base 16. And it should return, what is it, 2596? I should remember that. It's my favorite hexadecimal number. Well, it doesn't matter. We'll be calculating it here in a few minutes. Well, here, let's just calculate it. So we have the string BAD. This is the ones place. This is the 16s place. This is the 256 place, right? Now B, A, and D, in order to represent numbers greater than, so I probably shouldn't have started with hex, but we'll just do it real quick because hex is the sticking point. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That takes us all the way up through the base 10 number system. Base 10 numbers are represented as a collection of digits between 0 and 9. Well, as soon as we get above base 10, we don't have individual characters to represent the numbers. So we go to A, B, C, D, E, F, G, E, F for base 16. If you go base 17, you'd have G. Base 18, you'd have E, right? All right, remember your homework is supposed to work up to base 36. So it should work, yeah, so it should have the whole alphabet in it. All right, so an A is a 10, a B is an 11, a C is a 12, a D is a 13, so on and so forth. So this B right here is actually an 11. This A is actually a 10. And the D is actually a 13. That makes sense? So to do this math, we have 256 times 11 plus 16 times 10 plus 1 times 13. So 256 times 11 plus 16 times 10 plus 13 times 1, just for
Yes.
2989? 2989. All right, so BAD is the number 2989 in decimal. So if we were to pass into our method, once we have it written, the string BAD, and pass in the radix of 16, it should spit out 2,989. That's the equivalent base 10 number. Okay? Now, we'll leave that up there for right now. Let's take a different string. If I pass in the string, let's just keep it 3 digits to make this easy. 110, like that. This is the ones place. This is the twos place. And this is the fours place. Similarly, this is 2 to the 0th, 2 to the 1, 2 to the 2. This is 16 to the 0th, 16 to the 1st, 16 to the 2nd. Make sense? Okay, so the way we convert numbers is identical regardless of the base. The only thing we had to do special is this mapping. All right, so we're going to make this initially work for all bases between 0 and, or all bases between 1 and 10. So we don't have to worry about ABCDs. Okay, let's solve the easier problem first. So notice we always start at the end of the string. We're always walking towards the front. Each time, this is always the ones place. Each time through, we multiply it by the radix. So 1 becomes 1 times 16, which is 16. 16 becomes 16 times 16, which is 256. 1 becomes 1 times 2, which is 2. 2 becomes 2 times 2, which is 4. If we were dealing with base 10, 1 becomes 1 times 10, which is 10. 10 becomes 10 times 10, which is 100, so on and so forth. So we're always doing the exact same thing. Start at the end of the string, walk towards the beginning of the string. Every time we take a step, every single time we take a step, what do? We multiply by radix, the current base we're working with. And we sum all of it up. Okay? Now, the other thing we do need to consider, though, is that this 110 is stored as a string, which means this is the character 0, the character 1, the character 1. We need to be able to get the values out of that. So if I have the char 0, how do I get the number 0 from that? If I have the char 4, how do I get the number 4 from that? So I have this. I have the char 4. And I want to convert that to the number. To the number 4. How do you do this conversion? Okay. So you can do it the stupid way. Okay. Well, it's not the stupid way. It's probably the hardest to understand way. Yeah, what he wants to do is he wants to take the Unicode value of this and do the math to get you to the Unicode value of this. Okay? So if I'm showing that to you real quick, here, let me just return -1 here so it stops screaming. So I'm going to say char C is equal to a 4. And I'll go ahead and say system.out.println the int version of C. All right? Well, here's the int version of C. So the Unicode character for the char for is 52. Make sense? Okay, so how do I get to the Unicode value of a 4? Well, what's the Unicode value of a 4? Four is an int. Well, we just saw there is no Unicode value of an int, right? It's a literal. So how do I do math? Well, we have this. 52 minus 48. So if I take that value and I subtract 48 from it, that gives me a 4. Okay? But if you just look at this code just like that, it's not real clear what's happening, right? You're kind of using math tricks, walking the Unicode character set. Nothing wrong with it. You get the right answer, okay? But I would say this is relatively difficult code to read, okay? Because this requires that, okay, why is he just randomly subtracting 48? Make sense? Okay, nothing wrong with it, but I think hard to understand. What if we did this? String s is equal, actually, let's call it map, is equal to, start with that, map dot index of c. Give me a 4. That is, it found the char 4 at position 4 in this string. That make sense? So using a string like this, I can pretty easily look up a particular character. Okay? And just real quick, let's make this return -1 again so it stops yelling. If I want to get the integer version of a, where is a located here? Bucket 10. So that exact same code maps a and b and c and d. F should be 15. See how that works? Okay, where in your model, you would have had to subtract a different kind of number, a different size number, not just the, what was it, 48?
I feel I did that way, I forgot. But to move from upper
Right.
to lowercase, I used that one.
Okay. All right, so this makes sense? All right, so we're going to use this map string. Actually, I'm going to use because I said we're only going to make this work for up to base 10 first. Baby steps, right? All right, so this allows us to convert a char version of a number into the int version of that number. Just having this one string and using index of. That's the index of trick, okay? One of our go-to moves in our toolbox. Then we have our loop that's going to go through our string called num from the end of it towards the beginning of it. I need to start at the end of the string, walking backwards towards the beginning of the string. What's the last legal position in num? Num.length minus 1. So I'm going to have a loop. For int I is equal to num.length minus 1. So that's the last legal position in num. What's the first legal position in num? 0. Keep going as long as I is greater than or equal to 0. And what do I want to do to I each time? Subtract 1. So it'll start off, for instance, at, if we are a 3-digit number here. So this is 0, 1, 2. So we'll start off at 2, then 1, then 0, including the 0. Okay? That's why we need to have the less than or the greater than or equal to. So we make sure we process that very first character. All right, so that loop right there takes I on a voyage between the last legal bucket of num and the first legal bucket of num, assuming we choose to use that integer I to access that. an individual bucket, right? So each time through, if I'm in my very first pass through this loop and I'm looking at this guy, how do I access the character 1? If this 421 is num, actually, hold on, this is my number right here, 110. So this guy has a length of 3, last legal bucket is 2, so I'm currently looking at I as 2, and this guy's name is num. This is my variable named num. How do I access bucket I of that? How do I get the character 0? Num.char at I. Yep. So num.char at I or in this case 2 would give me the value 0. That's how I extract that one value, right? So I'm just going to type that in. Num.char at I will give me a particular character. Now I need the numeric value of that character. Well, we saw up here, how do I get the numeric value of the character? Well, I use the index of. So I'm going to say map.index of what character? This character. So we know this will boil down to the integer version of whatever character this is. Make sense? All right. Now, I need to multiply that by something. Out here, we saw we had the 1's place, the 2's place, the 4's place, the 1's place, the 16's place, the 256 place. So I'm going to have to keep track of a variable that keeps track of the current place. And that variable always starts at 1. And then always gets multiplied by radix. Base 16, it gets multiplied by 16. Base 2, it gets multiplied by 2. Base 10 will get multiplied by 10. So on and so forth. So up top here, I'm going to have an int place, and I'll start that off at 1. All right, so I'm always going to multiply this guy by place. And then I'm always going to take place and set it equal to whatever it's currently equal to times radix. So the first time it'll be 1, then it'll be for base 16, then it'll be 16, then it'll be 256, then it'll be what, 4096? I think so. Then 16,535? Yeah. Oh, come on, that's awesome. 16 times 2, okay, is 256. 3, 4096. 4, ha! Boom. I don't think I could do 5. 5 would be the 4 billion number. No, it's not. Oh, it's not. We're not base 2. All right. Impressive up to base 4, or to power 4. All right, so in any case, we're going to take the integer version of the current character, multiply it by place. And what do we need to do with that? Well, we're taking all this stuff and we are summing a bunch of things together, right? Okay, so I'm going to have a variable that holds on to my sum. Int sum, and that's always going to start off at 0. So I'm going to set sum equal to whatever sum is currently equal to, plus the integer version of the current character times place. Then make place be the next power of radix. Walk backwards all the way to the front. Ultimately, we're going to return our answer, which is stored in sum. All right. So right now, this works for base 0 through, or base 1 through 10. Now it solves your homework assignment. Only thing we changed is the mapping. So now instead of just going 0 to 9, now 10 is A, 11 is B, 12 is C, so on and so forth. That make sense? So this is the answer to base to decimal. Now I know a couple of you had asked, well, what if num is has lowercase letters in it or something like that? Yeah, did I show you that method? More string methods. We see substring. Did I actually show you 2 uppercase and 2 lowercase? Yes. I did. For strings?
something about changing to lowercase?
Yeah, well, that was,
Because I used uppercase, so you.
Yeah, it's not a big deal because you could just assume they entered it in all uppercase. I'm fine with that for the homework. You don't have to convert it. But since we're assuming all these are uppercase letters here, because that's what I put in my my mapping string, I would just do this. Num is equal to num dot to uppercase. So now you're guaranteed that all the letters that are in num are uppercase letters. Okay, not important for the homework. For the homework, you could just assume that the person who's using your method used it correctly. They either put in uppercase letters for the hexadecimal values, or they put in lowercase letters for the hexadecimal values, in which case you would have made these all lowercase. Your choice, but you could assume that people used your method correctly. Okay? But this is the catch-all. I'm saying no matter if they pass me upper or lowercase hexadecimal digits, I will just convert it to uppercase so it's compatible with my map string. Make sense? All right, so that's base to decimal. So for instance, I can do system.out.println driver.base to decimal, and I can pass it in BAD and tell them that that is currently in base 16. And then run this, and I get my 2989. I could pass the exact same number in and say it's in base 25. Now I get 7138. BAD in base 25 is 7138. The ones place, the 25's place, the 15,625's place. So B is in the 15,625's place. The A is in the 25's place, and the D is in the 1's place. That's how we got that value. Okay, so if BAD was passed in, and I tell it it's a base 25 number, we get a different answer. Similarly, can that be a base 25 number? Sure. What are the legal digits in base 25? 0 through 9, and then A through whatever the 15th character, or over the, the 15th character of the alphabet is. Whatever. Whatever.
I think 26 or 7.
Yep. Okay, so this is a legal number, and this is the number 5. Why? It's a one-digit number, and it's in the ones place. Okay? ABC in base 10. It's not a base 10 number, right? It's going to give me an answer, though. It's going to still do the math because we did the math correctly. So like I said before, you can assume that people call your method correctly. But I'm actually calling the method incorrectly here. I'm giving it a number like this, and I'm claiming it's base 10 when it's not. That's not a base 10 number. So it's going to give me some math. It'll give me a value based on it being the base 10 number. But your method didn't have to give an error or anything for this. Okay? I always like doing base 10 to base 10. So 2,141 in base 10, convert that to base 10, should give me 2,141. Kind of proves how our math system works. Make sense?
Yes.
All right. So that's the first part of your homework. Then the second question was going the other direction. Decimal to base. So that's this guy right here. And let's look at how do we convert a decimal number to another base. Give myself a new piece of scratch paper here. So let's say I have the number 28. And I want to convert 28 to base 2. All right? So I'm converting 28 to base 2. I'm first going to divide 28 by 2. How many times does 2 go into 28? 14 times. Okay? So we're going to say 14. 14 times 2 is what? 14 times 2 is 28, with remainder what to get to 28? 0. So I record the remainders. So there's 0. Then I take 14 divided by 2. Just 7. 7 times 2 is 14. What does it take to get to 14? 0. So no remainder. 7 divided by 2 is 3. 3 times 2 is 6, with remainder 1. 3 divided by 2. 1. 1 times 2 is 2, with remainder 1 divided by 2. How many times does 2 go into 1? 0 times. 0 times 2 is 0, with remainder 1. All right. Then we read our answer from bottom up. So this is 11100. That's the number 28 in binary. Notice we stopped when we got to a 0. We're looking for patterns. Okay, we stopped when we got to 0. And we always read our answer from the bottom up. Let's look at another example. Was it 2989? What's BAD? So we're going to do 2989 from base 10 to base 16. Well, 2989 divided by 16 is what? Okay, of course it's 13. Just to show you, 2989 divided by 16. Whoa. Oh, I'm sorry. 2989 divided by 16 is this number, 186. 186 times 16 gives me that number, and we're 13 away from 2989. Okay, that's where we got a remainder. So 2989 divided by 16 is 186. All right. 186 times 16 is that number. And then we can take 2989 minus that number, and we get a 13. So that's remainder 13. Make sense? So 16 goes into 2989 186 times. 186 times 16 gives us a number that is 13 shy of this number. So we have 13 left over. This is 3rd grade math, long division. Okay? 186 divided by 16 is 11. 11 times 16 is 176. What does it take to get us to 186? 10. So we have a remainder of 10. 11 divided by 16? 0. 0 times 16 is 0, with remainder 11. We know we're done. How do we know we're done? Right there. We knew we were done over here when we got to 0. We know we're done here when we get to 0. So we keep dividing by the base we're converting it to over and over and over again until we finally get a 0. It's our quotient. And we record the remainders each time. Okay. Now notice I have these remainders. I need to convert these remainders though, right? A 13 is actually a D. A 10 is actually an A. An 11 is actually a B. Then you read the answer from bottom up, you get BAD. That makes sense? So the exact same logic we did over here for converting a decimal number to base 2, we applied to converting a decimal number to base 16. We just divided by 16 instead of dividing by 2. Make sense? Okay. So now, let's look at a couple of things up here. So I'm going to go up into main. And we're going to have int a is equal to 2989. And we know the very first time through here, when I take 2989 and divide it by 16, I should get 186 with remainder 13. Right? So we want to see how we get those values. System.out.println a divided by 16. Oh, I have to return just a P's Java for a second there. So there's my 186. And there's my remainder 13. Divide by 16 gives me 186. Mod by 16 gives me the remainder. Make sense? All right. But now, I don't want it to be remainder 13. I want it to be remainder D. How do I convert the number 13 into a D? How do I convert 13 into a D? Not index of. Map.char at 13. That will give me whatever's at position 13 of map, which is a D. Make sense? So what I really want to say here is map char at that guy. So give me the character that lives at the position of the remainder in my string map. So a divided by 16 will give me a number that I'm going to use again in a few minutes to divide that by 16 again. And I'll go ahead and map the remainder to its equivalent character. So in this case, it's a D. What if, let's see. Well, it doesn't matter. What if this was the number 3? Do we need to do the mapping for 3? No, we don't have to. We don't have to, but does the mapping still work? What's at bucket 3 of this guy? This is bucket 0, bucket 1, bucket 2, bucket 3. Bucket 3 of map is the character 3. Make sense? All right, so we've used our little playground up here to kind of figure out our math for this guy. All right, so we're going to start off with our number, and as long as our number is greater than 0, we're going to keep doing stuff. Okay, so let's start off with that. So while number is greater than 0, do some stuff. Now, I need to build up my answer inside of a string. Okay, so that 1, 1, well, I would build it up 0, 0, 1, 1, 1. If I was building it, so record the remainder, record the remainder, record the remainder, record the remainder, record the remainder. Every single time we record the remainder, we want to tack it onto a string. Now, I'm going to do it in the what seems like the most obvious way at first, but we're going to see it's backwards. Okay, so we're going to see I build the string 0, 0, 1, 1, 1. Okay, well, Got the right stuff, it's just in the wrong order. Okay, so we're going to start off by doing that. Okay, which I would have expected many of you to do. Okay, I would have expected, if not, probably most of you. Did anybody not do it that way who got it working initially?
I'm using a different algorithm.
Oh, you're using a whole different algorithm. Okay, okay. But the punchline is most of you would have built the string backwards because that's the order things are coming in, right? So this would have been a common mistake, but that's okay. You don't want to try to solve too much of the world's problem. So let's solve it backwards first, then I'll show you how you can fix it easily. Because many of you, I'm guessing, probably wrote a little method called reverse that just spun through and reversed it or something like that. Quick little fix, no harm, no foul. All right, so anyways, as we're whittling down number, so in this example, number is 28. Then number becomes 14. Then number becomes 7. Then number becomes 3. Then 1. And finally it becomes 0. And when it becomes 0, this while loop ends because number is no longer greater than 0. Okay? So we're going to start whittling down number. But we need to make sure we capture the remainder first. So I'm going to have a string here called answer. We'll start that off as the empty string. And each time through, and the reason I say we need to capture the remainder first is if I say number is equal to number divided by radix, and then I say number is equal to number mod radix, I will get a very different answer. I'm sorry, not, let's just call this remainder for a second. Even though I don't have a variable, just run with me here. If I say number is equal to number divided by radix, and then I say remainder is equal to number mod radix, I will get a very different answer than if I have done it in that order. Taking the remainder first preserves number into its original set. Then I can whittle down number. Okay? So I got to do the remainder first. So I'm going to say answer is equal to whatever answer currently is concatenated with number mod radix. Calculate the remainder, concatenate it onto my running string. Then whittle down number. Okay? Finally, we're going to return answer. We'll come up here. We'll say system.out.println driver.decimal to base 2989 to base 16. And we're going to see this guy, well, first of all, we didn't do our mapping at all. Okay, we see that this guy gives us DAB with our mapping. So it's backwards. But let's go ahead and do our mapping. So we're going to steal this string map from down here. And instead of concatenating on this number, we're going to concatenate on map.charat. That number. We're going to look up that number to get us the actual digit. Now we have DAB, which is our correct answer, but backwards. So we could write a little method or something to just reverse our string. Or what we could do is we could build our string in reverse. Okay? So every single time we concatenated here, instead of saying answer is equal to answer concatenated with map.charat, that, I can say answer is equal to map.charat that concatenated with answer. Just build it backwards. Now we get BAD. So now I'm always tacking on the current version of answer onto the end. So if the first time answer was D, the next time it's AD. The next time it's BAD, because answer is going on to the end. That make sense? All right. So that should be functional version of your homework. All right, questions on that? So not that much code in terms of total number of lines, but now things are getting more algorithmic, right? You know, we had to go in here and we had to understand the pattern we were going through and then capture that pattern programmatically. Make sense? So I think I even mentioned last time that this assignment is harder than the previous one. But my guess is many of you probably still struggled on this one quite a bit. But for those of you who finished it, probably felt that this one actually felt easier than the previous one, would be my guess. And that's not because it was easier, it's because you're getting better. That make sense? This stuff feels less foreign. Because this is the harder problem. Last time you were just walking a string and collecting some crap. It's not a big deal. Okay? But what was difficult about it was that we were juggling a lot of balls at once. We were having what's the current operator? What's the current number? You know, then somebody throws the running chainsaw in there, right? And that's always dangerous. You seen that commercial? I love that commercial. It's one of the insurance company commercials or something like that. And the guy's wife is telling the insurance person about, I think it must be, what's her name? Flo from Progressive. I think it's a Progressive commercial. And the guy's saying, the lady's saying, oh yeah, our prices are better than ever. It gives people overconfidence. And it says, oh, that explains a lot. It shows a video of the husband. He's at like a circus or something like that. And there's this dude holding like a flaming something in his mouth, juggling running chainsaws. And the husband just walks up and says, come on, I got this. Give me one. Just give me, because he wanted to help juggle running chainsaws. You should never juggle running chainsaws. Computer scientists should never juggle running chainsaws. We need our fingers. Okay, well, in any case, the last assignment for many of you was like juggling running chainsaws. We have a lot of stuff in the air at once, and our mind gets all gobbledygooked, right? Okay, and for those, when those of you who keep asking questions, is why I keep telling you, when you submit your homework, make sure you're doing the self-evaluation. I know when you spent 10 hours on an assignment, you have more than these 4 lines of code to show for it that don't work. Okay, you need to tell me about your experience. Because when I hear about your experience this week, and I look at your experience next week, and I look about your experience the week after that, I start seeing improvement. Some of you already have seen it for between last week and this week. Last week's assignment was substantially easier than this. But for many of you, it probably didn't feel like that. This one felt easier because you're better. Make sense? All right, so keep that in mind. Like I said, it's not my first rodeo. Programming is hard. You're supposed to suck at it for a while. But you got to do your part, and if you're only going to turn me in 4 lines of code for a solution, well, you better give me the human version of what your hell was like this last week. Make sense? I need to know that. Okay? Not because I'm going to feel bad for you, but that fills in the gaps of what I'm missing right here. I want to know that you're working hard, and I want to know where your weaknesses are. Because that might just give me one little piece of ammunition where I can throw something your way, and all of a sudden a lot of these things come together. Make sense? All right, so like I get paid regardless. If you guys suck at this, check's in the mail. All right, but programming is hard. And you have to understand that as you're doing this. You're supposed to suck at it. It's supposed to take you a long time. You're not supposed to be able to just sit down and power through it. If you can, you're ahead of the rest of the class, and good for you. This isn't going to be an easy A, right? Yeah, you got to take the class. It is what it is. Life goes on. But for most of you, you're probably spending 8, 10, 12 hours on the homework, having lots of problems, sometimes not even finishing it. That's normal. That's par for the course. You can hate me all you want. I'm big. Okay? I promise you, you will get better. All right? And you will usually see at the end that your grade ends up being numerically better than it should be, assuming you've shown me that you've improved. Those of you who have my classes before, you usually end up with a better grade than you numerically earned. Okay? As long as you show me that, hey, I sucked really bad here. I just pretty much suck now. But I used to really suck. Make sense? That's called improvement. Okay? Probably won't get you an A, but it'll get you through the class. I do understand that there's some like student visas and stuff like that I have to take into consideration, but I won't hand you a grade, but I'm not just going to blanketly fail you for effort. That's what I'm saying. Okay? So you work hard, and I think you'll find that I take better care of you than I should. All right. Let's see. What are we supposed to talk about today? Oh, yeah, that's a good paper. Okay, good. I wasn't lying earlier. We are talking about arrays today. Does that make you feel uncomfortable that I have to go and look at what the assignment is to determine what we're talking about today? It's like a ticking time bomb type thing. How bad is this going to be? Okay, so we need to start talking about something called an array. So sometimes we need to store more than one value inside of a single variable name. Okay, so for example, we might have something called this week's lottery numbers, or just lottery number, or something like that. And it might be helpful for us to create a single variable called lottery numbers and store the 5 lottery numbers, however many lottery numbers there usually are, whatever it is. Okay, rather than having lottery number 1 is this, lottery number 2 is this, lottery number 3 is this, lottery number 4 is this. Okay, so we have a facility in modern programming languages known as arrays. Some languages call these lists. So there's for instance, lists in Java are different than arrays. But in other languages, for instance, Ruby or Python, a list is an array. It's how they're implemented. So it's not so important what you call it as much as what it does. Okay? So an array is a collection of like data stored contiguously in memory. Okay. Now, obviously, that's perfectly clear to you, right? So we can just move on. Okay. Contiguously. What does contiguously mean?
In the nearby address.
Huh?
In the nearby address.
Nearby?
Maybe like
Nearest
continuous.
Okay, one after what? So I think you were saying the same thing. Okay. Contiguously means in a row, one after another, right next to each other, whatever. Okay. So we're going to have a collection of like data. That is a whole bunch of integers, or a whole bunch of chars, or a whole bunch of booleans, or a whole bunch of strings. So a collection of things that we can create variables of, stored in this array, where in memory each of those elements must live right next to each other in memory. Okay, that's an important caveat of arrays, and we're going to talk about it a lot today. So you'll like this, because you know how we just talked about hexadecimal stuff. All right, well, we're going to talk about memory today, and I think I even gave you a little foreshadowing for those of you who went and bought one of those Untitled books or something like that. If you you asked me about it the first day of class, if there were some helpful Java books that you could get. I said go on to eBay or something and buy version 2 or 3 that the language hasn't changed from our perspective and pay $2 for it. But most of these Java textbooks talk about pointers, the idea of a pointer not existing in Java. Well, real quick, what's a pointer? Well, a pointer is a primitive type. Now, what's a primitive type? It's way back at the beginning of the
Only store one value and it's a building type.
okay? So it's a type built into the language that's only capable of holding a single value. Can't do any other magic tricks. So can't do the stuff like strings can do. Strings have other magic tricks, right? Index of, char at, length. Those are extra stuff strings know how to do. Okay? And just as a hint, for the 2/3 of you that find the programming stuff the hard part of this class, it will do you a lot of good to really get good at answering questions like, what's a primitive type? How do you call class methods? How do you call instance methods? If you're looking at the method definition, what does the class method look like? If you're looking at the method definition, what does an instance method look like? All those little things, most of the final exam will be that stuff. Okay? And then there'll be the proverbial 1 or 2 programming questions. So you bomb those, you get your 80 and get out of here. You see what I'm saying? Some of you just aren't going to be able to come in on the final and perform the programs. Just you're not going to be ready. And that's, I said it first day of class, that 8 weeks for a course like this sucks. I already know the stuff. You don't. And compressing this into 8 weeks is a problem. But it is what it is. You guys, a lot of you are working professionals, and this is why we have our evening class and stuff like that. It's just the nature of the beast, right? So at the end of 8 weeks, even though you're going to see improvement, you will know that, oh, I've gotten a little bit better, a little bit better, a little bit better. Well, you might not be good enough to write the programs in real time, on paper, with any sort of competency to show that you've mastered the programming side of the material to where you need to be. But the rest of it is memorization. Okay? But it's not just useless memorization. It's things that will come in handy because you apply it when you're programming. If you can look at a method and immediately tell how to call this guy, you see, oh, there's the method definition. It's a class method. How do I know? Well, it's static. How do I call class methods? I use the name of the class in which the method was defined. So I call this guy by saying decimal dot decimal to base. Or I'm sorry, driver dot decimal to base. Make sense? So knowing those things just off the top of your head tells you a lot about what you need to do to be a good programmer. The other part of it's practice. Okay? So for those of you who perceive that you suck at programming, it will behoove you to learn those things very, 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 very well. Then you'll get your reasonable grade on the final and life goes on and all that crap. All right? Also, and there's 2 people I mentioned this to, if you're falling behind in here, I know for some of you, having to keep a student visa, you have to take on-campus classes. But there's a version of this course called 835. That's an online version of this course that is self-paced. So you can take your time with the assignments and things like that and turn them in when you are done. I think they gave you 3 months or something like that to do the whole course or whatever it is, something like that. But you won't have a paper and a program due every week. You can do it at your own pace. So if you are finding it hard to keep up and an A is really important to you, well, then you might consider switching over to the 835. You can still sit in this class if you want. I don't care. Still learn the material, but you might choose to take the online version, which would spread out the assignments a little more. And it's the same assignments, so we can just transfer those over if you want. So it's up to you. A lot of the reason we have the on-campus version of these classes is mostly for student visa issues, where you have to have so many in-person contact hours in order to keep your student visas. Again, is what it is, but whatever. So do let me know if you're interested in that. We can figure out how to just flip things over or something like that, or I'm sure with working with Dr. Locklear, we can figure something out. Because it doesn't make a difference to me. The content's already up. That's why when you go into Angel, you see all these videos, because you're seeing the 835 class, the online version of this class. I'm just giving you the refreshed version of the videos. You know, the sequel, always better than the original. All right. So, let's see. We were just talking about arrays. Okay, what's a pointer? So a pointer is a primitive type value that is capable of holding a memory address. That's it. Integers are primitive type values capable of holding numbers. Doubles are primitive type values capable of holding floating point numbers. Chars are primitive type values capable of holding characters, which are actually holding numbers, which map to characters on the Unicode table, right? Strings are primitive type values capable of holding what? It's not a primitive type, right? Strings are object types. Tricked you. I didn't trick him. I tricked the rest of you. Yeah. Strings are object types, not primitive types. Why? Because they have magic tricks. They have other things that they can do besides just hold a value. Okay? But pointers are a primitive type value that's capable of holding a memory address. Now, most Java textbooks say that Java does not support pointers because they don't specifically have a pointer primitive type. They don't specifically have a special syntax for designating something as a pointer. Fair enough? Okay, well, I'm going to show you something here real quick. I'm just going to define a array real quick. Let's just get rid of this crap. Okay, now, we'll talk about the syntax here in a second, but I just defined an array. This guy's going to hold a collection of 10 integers. That's what that dude is right there. Okay, this is a variable, right? Why? Well, because the generic syntax for variables is what? Type name equals value. Type integer array, name, AR, value, all this crap. Make sense? Okay, so I'm printing out the value stored inside of AR. Okay, now earlier, when we were talking about the use of hexadecimal numbers and octal numbers and all that stuff, one of the things we mentioned is that memory addresses are usually represented using hexadecimal values, right? Because memory is really, really, really big, and if we need to index all these individual buckets of memory, having a smaller footprint is beneficial. Okay, but now remember, just don't forget that pointers do not exist in Java. They don't exist. What the heck is that? That's a hexadecimal number, first of all. This is the address where this integer array lives. Hold on a second. Primitive type value that's capable of holding a memory address. That's a memory address. That's a pointer. But wait, whoa. The books say no pointers, but that's a pointer. What's up? Could all those books be wrong and only me right? It wouldn't be the first time it's happened.
How we control it?
Huh?
If we want to jump to another address.
What if I want to jump to another address? Here's the issue. Many of the books misrepresent the idea that pointers do not exist in Java. The reality is Java does not have a specific syntax for pointers. because everything is a pointer. Okay? So what's funny about that is when a textbook says that pointers don't exist in Java, what they really should say is everything in Java is a pointer. Or pointers only exist in Java, or only pointers exist in Java, something like that. Okay? Java doesn't give us a special syntax for dealing with pointers because everything's stored as a pointer. Other languages like C or C++, they would allow us to have well, here, let me just do it out in a comment out here. I could do something like this. Int a is equal to 5, and then I can do a print f. Well, let's just do Java syntax since it'll be sudo. System.out.println a would give me the 5. System.out.println will give me the address of that integer. Similarly, I could say integer pointer b is equal to 7. And then I could say system.out.println b, and I would get the memory address. Or I can say system.out.println star b, and that would give me the value at that memory address. Okay? So older languages like C and C++, they gave us a special syntax, an asterisk here, to define a primitive type. This is a integer pointer. It's a primitive type variable capable of holding the address where an integer lives. They also gave us a special syntax for accessing the address of a primitive type. They also gave us a special syntax for accessing the value stored at an address. Why? This guy's a pointer. How do we know? Well, his type is integer pointer. What do pointers hold? They hold memory addresses. Sure, I developed this guy to hold the number 7, but behind the scenes, what actually got created is a memory address, and I stuck 7 there. So if I go to print out the value of b, that variable is a pointer whose value is a memory address. If I want to get the actual value that lives there, I have to say star b in these other languages. Okay? Now, that's certainly easier, isn't it? Wouldn't you rather have stars and ampersands all over the place than the Java way of doing things? Sure, it's just more crap to remember, right? No big deal. Well, so tell me about pointers. Why do we need these guys? Java's made a decision. They've decided, you know what? We're just going to make everything pointers. Now, that's actually somewhat of a lie. Java intelligently decides what to treat as a pointer and what not. And we'll look at that by example today. Okay? So Java makes the right call. Older languages like C and C++, while very good languages, and I'm making the assumption that you've had some C and C++. Okay? Anybody else had C and C++ before? Okay? So those people are going to be familiar with this idea of pointers and the syntax dealing with stuff. And historically, pointers are always, Eclipse doesn't like me today. Pointers are historically difficult for students to learn. And it's never made sense to me because they're such an easy concept. But as soon as we start seeing weird hexadecimal stuff, we get very afraid. Right? We like base 10. Give me the number 45. Not intimidating at all. Okay? Give me some crazy hexadecimal value and I start crying. Right? It doesn't make sense to us. Okay? So it's intimidating, so we end up thinking it's difficult. Here's the problem with these older languages. And this is going to become more and more of an issue as we get into objects. But we can explain it at the high level here at least. So let's say that good example would be a real life example here. So let's say you're having a party at your place. Okay, you said 10 blocks from Solly's.
Yeah.
Okay, but that doesn't tell me too much, right? So you're gonna have your party. So instead, what you're gonna do is you're gonna say, "Hey, Mike, here's my house. Open the door at 8." You're going to hand me your house, right? That's what you're going to do?
Yeah, exactly.
Okay. Oh, hold on. Now you're going to give me the address to your house. Well, what fun's that? Okay, you're inviting me to your party, right? And you're going to hand me the house.
Sure.
All right, because he's already started on the alcohol. All right? He's hitting it hard, okay? And he thinks he can lift a house. All right? So he's going to say, hey, here's my house. He didn't tell you it's a Maytag box, and even those can be kind of hefty. But the point is that would it ever make sense for you to hand me the house as opposed to tell me where I can find your house? In real life, it would never make sense to hand me the house, correct? That would always be ridiculous. Okay, if somebody comes up to you and tries to hand you a house, first of all, be impressed.
Why is he handing me his house?
Well, yeah, be weirded out, definitely. But if this dude's carrying around a house like it's a pizza, okay, start off by being impressed. Those things are heavy. Even little houses. You know, isn't that the new thing, the little mini houses? The tiny homes? Have you seen those? It's like a Discovery Channel. There's these people that are creating these little modular like huts. And they have like really small footprints. It's like basically a huge doghouse. And they have like slide away beds and stuff. It's like super functional. So it's like the new way of living is these small homes that have really small power bills and not a lot of space in them, but like really maximize the space. Yeah, it's kind of like the Doctor Who.
Oh,
It's
yeah.
bigger on the inside, right? The TARDIS. You don't watch Doctor Who?
I watched Doctor Who.
Oh, you have to watch Doctor Who. You're technologists.
Very famous
Yeah, Doctor Who.
British comedy.
Yeah, it's British. See, it's not even written by dumb Americans. Oh yeah, Doctor Who's great. Yeah, it's on Netflix. Go check it out. But he has this time machine called the TARDIS. Doctor Who's a time traveler.
It's a telephone.
Okay, it's a telephone booth, but it's called the TARDIS, and it's bigger on the inside. So you look at it on the outside, it looks like a telephone booth. You go on the inside, things like like one of these Las Vegas hotels, just infinite rooms, right? Okay. So in any case, that's the whole thing with these mini homes. So even one of these little mini homes, which are huge dog houses, all right, 5, 6, 7 times the size of a dog house, even that would be ridiculous for you to hand me your house and tell me to open the door at 8. Correct? It doesn't make any sense. You're always going to tell me where I can find you. Okay? You're going to give me the address. Well, that's not intimidating at all. In real life, I expect an address from you. Correct? I don't expect you to give me the actual house. I know what a house is. I'm comfortable with houses. But I'm even more comfortable with an address. Punch it into my GPS. It'll take me right to your doorstep. Right? Okay? No harm, no foul. Addresses don't scare us in real life. Why do they scare us in computers? Because the hexadecimal. They look scary. Okay? Well, so here's the punchline. These older languages like C and C++, why have they been replaced with these newer languages, and why have these newer languages removed the syntax for pointers? C# has done it as well. Okay? C# has a special block called unsafe. That if you really, 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 really want to use pointers, you can. But you have to wrap it inside of a control block that says unsafe. Okay? First of all, if you're ever writing a line of code that says unsafe, you probably should be thinking about it, right? Like, why am I writing something inside of something that says unsafe? But whatever, it's neither here nor there. Okay, but the punchline here is this. And actually, the unsafe thing kind of goes along with what he was saying, because you can't actually directly manipulate memory without that. Which you can get by without doing that, but sometimes it's helpful. But don't worry about that for right now. So here's the punchline. Why did Java remove all the syntax for dealing with pointers? Well, that's one reason, but not the reason. Okay, that's a benefit. That's a benefit of it. But realistically, you've just finished telling me it never, 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 never makes sense to hand me the house. It always makes sense to hand me the address where I can find the house. Older languages like C and C++, they empowered the programmer to make dumb decisions. In C, you could choose to hand me the house as opposed to hand me the address to the house. Okay? So replace house with some large data structure that's taking up 2 gigabytes of space. Rather than tell me where in memory I can find this guy, you're just going to, you ready for it? You ready for it? You toss it in as a parameter, hit the other guy, he goes flying back. Okay, you're passing around a 2 gigabyte chunk of memory, but not the actual. You're not telling me where to find it. You're dragging it with you. Never, never, never makes sense. But C and C++, with the special syntax for pointers, empowered the programmer to decide to be stupid. They allowed you to be a bad programmer if you chose to, or more commonly, if you didn't know what you were doing. You would accidentally pass it by value as opposed to passing it by address. Make sense? All Java did is it said, we're not going to let you make dumb decisions. Instead, you just pass the variable name and we will figure out what's the smart way to deal with it. If you're going to pass a house, we'll make sure we pass it by address, not by house. Okay, not by value. That make sense? All right, so one of the things we're going to have to accomplish here is we're going to have to discuss the difference passing variables. We can pass by value or we can pass by address. Pass by value sends a copy of the value as a parameter. Okay? So in our unreasonable example, this is pass the actual house. Okay? But in a more reasonable example, this could be pass an int. Pass an integer. Yeah, I will. I'm kind of setting us up for the second half. Otherwise, I'll drag us like to 8:20 before we take a break. So I'm getting us up to about 8, and then I will show you examples. Promise. But you have to pay for it. Okay, so pass by value means we're going to take a copy of the value we're sending, and we're going to pass it as a parameter. So in our bad example, you're handing me the actual house. But in a reasonable example, let's say I need a quarter. You're not going to go tell me where to find a quarter. You're going to hand me a quarter, right? You're not going to say, you know what? If you go down this street, behind the garbage cans. Okay, you're not going to send me in this wild goose chase telling me where a quarter lives, right? You're going to reach in your pocket and hand me a quarter. These quarters are nice and light, and it's completely reasonable to give me a quarter. Not reasonable to hand me a house. That make sense? So, the important thing here is pass by value is not inherently bad. You just need to use it appropriately. You pass a value when it makes sense. You pass an address when it doesn't. Houses should always be passed by address. Quarters should always be passed by, by value, right? So just as ridiculous as it would be if somebody's walking down the street carrying a house, if you ask somebody to borrow a quarter and they start to give you instructions where you can go find one, that's going to creep you out, right? That's weird. You go find somebody else who lends you a quarter. Not this guy who's going to tell you where you can find his stash of quarters. Actually, that just got creepier when I said that. Why does he have a stash of quarters in the first place? And why does he have the instructions written on a piece of paper? All right. So, the alternative to pass by value is pass by address. This sends a note with the address of where the actual value can be found in memory as a parameter. So instead of it giving me the actual value, it hands me a variable with the address of it in there. So you're telling me where I can find the house. You're going to write it down on a napkin. Okay? You're going to hand me that napkin. So that's a variable. You're going to hand me that napkin, and on the napkin you've written down your address. I can type it into my GPS and I can go find the house, right? Okay, so you'll pass houses by address. Makes sense. In that case, it makes good sense to pass a house by address. So that's pass the house. Pass the house by giving me the address. And we've already covered that it really doesn't make sense for you to tell me where I can find the quarter. It makes a lot more sense to just give me the quarter. Correct? All right, so the important thing that comes out of this is don't view pass by value as being inherently good or bad, and pass by address as being inherently good or bad. Each of these has their place. In older languages like C and C++, we were, as programmers, empowered to make that decision, which is fine for a programmer who has a background, who's got some competency in it. Because typically, and human beings, we'd be fine with this, right? You know, we make that decision. You would never, in a million years, consider handing me the house. You would right off the bat say, okay, I'm inviting Lippman to my party. We're going to tell him where to find the house. Okay. You didn't even waste 1 second thinking, well, should I just hand him the house? Because you're competent at problem solving, right? Okay. Well, computer programming is something we're not as competent at. So now you have this special syntax for doing things. We could certainly, in real life, you would never accidentally hand somebody a house, right? You would know, and so would your shoulder. Okay, you would never accidentally hand somebody a house in real life. But in C or C++, the only difference is a missing asterisk as to whether or not you gave me the house or gave me the address of the house. One little tiny typo. You may have even meant to send me the address, but forgot to send me the address. Instead, you sent me the house. Okay? So, rather than empowering the programmer to either make bad decisions or make silly mistakes that don't break your program, that's kind of the important thing there, is passing something by value when it should have been passed by address will not necessarily make your program crash. It just makes your program memory inefficient. So now you have a program that is taking up way more memory than it should because of a stupid little mistake. That didn't mean you didn't know what you're doing, it just means you forgot an asterisk. Well, actually, that you added an asterisk in that particular case. Doesn't matter. Make sense? So Java says, you know what? Why don't we just automate that? Let us make the call. Okay, if you're passing an object, we're going to go ahead and we're going to pass it by address. We'll take care of it. Don't worry about it. Okay, if you're passing a primitive type, we'll take care of it, but we're going to pass that guy by value. And I'll show you examples of how we know that's true after we come back from break. Sound good? All right, questions about any of the crap we've talked about in this first half? All right, let's take about 15. Then we will show those examples and keep on cooking.